Okay, ji, it's week third, and we will be starting with some of the new topics. I just thought that it is important to tell you something about the core, that what is the importance of core in reservoir geology. Because when I was intern at OGDCL RMD department, then there were guys who visited HDIP, Hydrocarbon Development Institute of Pakistan, to visualize the core. So what would be the purpose of core in reservoir geology? Today, we will try to look at some of the aspects and some of the importance of core in reservoir geology. That is very essential. That is very basic. Obviously, you have idea about the core, its importance, but obviously we need to revise some of the basic aspects of core. And now we are in the phase of the architecture, the internal architecture of the reservoir. So it includes everything regarding the reservoir. So core is one of the prime important component, and you need some experience to visualize core. I think the geology of the reservoir starts from describing the core. Okay, let's look at this workflow, that what includes in the core analysis. The first part is geology. The second one is routine core analysis. And then we have special core analysis. In geology, we can inherit facies, diagenesis, sequence stratigraphy, geological rock typing, fracture analysis, paleontology from the core description. Obviously, when you have core in front of you, you will be looking for the facies description. Normally, we use this facies term in industry for the descriptive description of different rock units, but obviously the true definition of facies would be a little bit different. Like these are the slope deposits, are the gravity added deposits, we can say. Like in the Tobda formation, we have three kinds of facies are there. Then the diagenesis, obviously by looking at the core, we cannot just tell the history of the diagenesis. We need some microscopic and macroscopic experiments. Obviously, we take some of the samples from the core plugs, and those samples undergo different experiments, petrography, petrology, and then we can come up with the true diagenetic pattern of that reservoir. Then sequence stratigraphy is very important. Whenever you look at the core, you need to identify the different cycles of sea level changes. Obviously, with the change of different patterns in the facies, different beds, they demarcate different boundaries. So you can get the overall idea about the sequence stratigraphy by describing the core. Then geological rock typing, based on the number of observations, you can identify the rock types as well. Then fracture analysis, somewhat it is easy to identify fractures via cores, but sometimes you need thin section preparation for the identification of some very small ultramicroscopic fractures within the rocks. Obviously, fractures are present in carbonates as well as in sandstone. Then paleontology, again, paleontology needs some microscopic studies. Then most importantly, the porosity, permeability, and water saturation. These are some of the most important reservoir characterization techniques, are the fundamentals of reservoir that we eventually uses in our petrophysical analysis as well. Obviously, when you go for petrophysics, the first choice would be to use porosity or permeability. If you have the porosity, permeability, and water saturation, then you can easily get the hydrocarbon saturation through simple calculation or through the use of RC equation. Then gamma ray logging is very important, just in order to get the depth matching with the core that we retrieve from the subsurface. Obviously, the core retrieval is a tedious task for exploration companies. It's much more expensive, and it requires a care throughout the drilling process. So in different fields, it is not possible to get the core for every well. Obviously, we have some limitations of the tool as well. So we run different types of logs in the subsurface, like gamma ray, resistivity, neutron, porosity logs, to get the same values using logs rather than via core. And ultimately, if we have core and if we have the logs, then we correlate our values, our interpretation. So our petrophysical evaluation, it's for all those guys who are having the petrophysical course in MS1. If you have the values from core, then they would be considered as the best petrophysical properties and the most authentic one. If you are getting those values from different equations, then they are not much more reliable than the values we get from the core measurements. Okay. Then some special core analysis. Obviously, we need to perform some special core tests as well. The relative permeability, capillary pressure, Archie factor, and wettability. By combining all these special core analysis tests, we can make a dynamic model for the reservoir. Some of the routine core analysis, they can help us to build a property model. Property model mean we make one model and distribute the properties away from the reservoir. Then by using these Fashi's model, by the implication of diagenesis, sequence stratigraphy, we can make conceptual model, conceptual depositional model for a reservoir, or we can go for structural model. By to construct a structural model, we can also take the help of seismic data and image logs as well. Then there is a small component that is geochemistry. This field is relatively new, but this is very important regarding the origin of the rocks or the origin of the reservoir. We use some isotope analysis, some geochemical logs to get an idea about the origin of the rocks, like carbon isotopes, like some of dating, like argon dating, some of the experiments like to know the combination of reservoir to source rock correlation. We apply these geochemical methods to evaluate the overall dynamics of the reservoir. So these are some of the areas, I would say gray areas, where you need to work more. If you are doing your thesis of MS, that is obviously that is going to be the best document you are going to produce before PhD. So if you are working in this area like upper Indus Basin, so there is a room to work on the source rock correlation. This is a very simple technique. Obviously, it's the cost is involved in this technique. You need to come up with the some samples of source rock, then some of the tests available for reservoir. You can even use the crude oil for that geochemical tests as well. So if the properties are in match, then you can find that this reservoir is getting production from this source rock. Like if I say that if you go to Eastern Salt Range, then we have one reservoir just above the salt range.
Kevada, sir.
Kevada sandstone. So,
Yes.
so there is a source rock beneath Kevada sandstone. And if you just want to know that either this source rock is charging the Kevada sandstone, then you have to go for geochemistry of the of that reservoir and that source rock. If the results are matchable, then you easily predict that either it's a charge for Kevada or not. So these are some gray areas you need to carry out your research. So any problem with this slide? Yeah, any question you would like to ask?
Survivability.
Wettability.
Terms, sir, used.
Wettability is like if you have uh, one solid, then
Okay, sir.
the amount of fluid that retains on the surface of that solid is wettability. Why it is important? Why
Okay.
the rest of the Archie factors are important? Archie factors is cementation, and that is the value of M and N. Obviously, you have seen these components in petrophysical analysis. And then capillary pressure, then relative permeability. Relative permeability means in a reservoir, we have multi-phase flow, like we have oil, we have gas, we have water. The permeability of the one fluid with respect to the permeability of the other fluid, or it's a
Okay.
ratio of
Relative permeability.
effective permeability to the permeability that is of on 100% saturation of the other fluid, that is absolute permeability. So there are various types of permeability. Obviously, in our next lecture, we will be talking more in more detail about permeability and porosity and their interdependency to each other. So relative permeability, capillary pressure, Archie factors, wettability, these are the special core tests. Obviously, some of the tests like capillary pressure or relative permeability, I don't think so. These are capillary pressure is not available in Pakistan. I don't know about the relative permeability. Permeability and porosity are available. Wettability, I don't know. So the purpose of this slide is the core analysis. Core analysis uh, uh, is the very basic step, and it yields so much information about the reservoir that our petrophysical evaluation is totally dependent upon porosity, permeability, and water saturation that we get from the core. And we can get so much information from the core. Even we can isolate, we can make some reservoir zones as well, which one is productive, which one is not. Let's move further. Okay, the left hand side picture is a floor guru or sambar shale. Okay, uh, I took these pictures last time I was working at HDIP lab. So these are from the sambar formations. Look at this. This is a carbonaceous shale, and we are just talking about this, the unconventional potential of this shale. This is a sambar shale. You can see the boxes. Uh, uh, every company is bound to provide this data to the HDIP that runs under the guidance of Ministry of Petroleum. What do? They slab the core into um, uh, two slabs. They make two slabs. One slab they kept for their R&D, and the other slab they send it to HDIP. But on the right hand side, we have a complete core that is probably from OGDCL, as they sometimes down further to make the slabs for their R&D. So what is the difference between the picture that is on right hand side and that is on left hand side? Could you interpret?
The left one is the core shell samples,
Okay.
and then the right one I think it's sandstone.
Right one is a sandstone up till here, but we have some
Yes.
shelly packages over here. So whenever you go to describe the core, you always start from here. Let me. If you start from here, the first thing we are going to note is the boundary of the bed. This looks like a homogeneous bed. This is my interpretation, and this is a picture. If I'll be looking at this core at HDIP, then the interpretation would be different, because the in order to observe the core, you must have hand lens with you, and also you must have some HCl in order to characterize the calcite or carbonates. So this could be different, but eventually what it is saying to me is that this bed is continuous. Okay, you can call it a massive bed. Okay, massive sand bed. Maybe it's a medium fine grain, fine to medium grain sandstone. Okay, uh, uh, and the thickness, you need one measuring tape to just to measure. Your measurement starts from bottom to top, then from here to here. So this is a continuous bed, and it eventually ends up over here. At the top of it, we have a shale, and so we can say that this is from here, from bottom to top of this bed, we have one lithology, that is shale, and you know the characteristics, that is a fine sand. So based on this, you can uh, say about the depositional environment of this particular lithofishes. Then moving here, you have to describe every inch or every feet of this reservoir as well, that what you have in the clays, in the sand, either it's an interbedded shale, or uh, or it's a different type, or you have some interbedded shale and sand sequence as well. So if we talk about this shale, this is particularly looks like a black shale. Black shale is obviously depicts a good carbonaceous material. So this is how we describe the core. So this is the area under our investigation. So left hand side, we just measure this core. It's about 75 centimeters, and they preserve all the cores in designated core boxes. So what you can see in the right hand side image, anyone? This is
I think it's sand.
Usually coarse grained, sir.
good. This is a coarse grain sandstone. Okay, this is coarse grain sandstone. And what about the middle one?
This is fine grained, sir.
Fine.
This is fine grain. Good. This is fine. This is coarse grain sandstone. This is fine grain sandstone. But this seems to be a homogeneous by just a physical observation. But I can't say this is homogeneous. But obviously the heterogeneity or homogeneity, they depends upon the scale of observation. If we make a thin section out of this, then probably we will get some of the heterogeneity from this section as well. You can see these are some of the features. Looks like a clay balls. Look at this part. This is black. This is a black. These may be a clay balls in the same coarse sandstone reservoir. And then,
Sir,
yes, please.
sir, what is the importance of homogeneity or heterogeneity for reservoir?
Heterogeneity exists everywhere in every reservoir. Earth is not a homogeneous material. Earth is heterogeneous. Heterogeneity depends upon the scale of measurement. As I said, we have 1 week to discuss heterogeneity and homogeneity of the reservoirs, how we can calculate the heterogeneity in the reservoir. But obviously, if I say that by looking at this reservoir, I can say that this looks like a homogeneous reservoir from top to bottom. If we consider the grain size,
Yes.
but if I make a thin section out of this reservoir, that will give me some additional information about the grain size, that we have something additional. Either these are clay balls, either these is a carbonaceous material, or these suspended particles of the clay. Or this is another thing, that this is a carbonaceous material or a clay. So if we go towards the petrography or core section analysis, then it would give us the heterogeneous results, that it's not the homogeneous part, this is highly heterogeneous. Okay, same is here.
Okay.
If we look at the bottom and the top, this looks more heterogeneous. That the clay balls are there. Then it's a fine grain sandstone. You can see the variations, a little bit variations. like here, like here. So I worked on this. These are some of the calcite layers. Some of the side are cemented as well. This is the impact of clay. These are the isolated clay balls as well. So to describe a core, you need experience and the literature available for the same formation. Obviously, once the things will undergo microscopic or macroscopic observations, they will give you the additional information about the particular reservoir. I will keep on sharing the results of my research as well. So on the left hand side, we have one document. You must have this document with you while going to describe the course in the in HDIP or in any lab of the world. Okay. So what it says that you need to mention the depth. Like I divided this into, I said this is 10 centimeter, this is 20 centimeter, 30 centimeter, and goes up to 100. So this is the core description. As the reservoir was sandstone, so I use this graph that starts from shale, sandstone, very fine grain. If it's silt, shale, then I will draw a line uh, of 10 centimeter, that the 10 centimeter part is of shale. Then I can write down a facies description that we have shale, uh, fine grain, or we have sandstone uh, intercalated with shale, or we have fine sandstone beds with some clay balls. So this is the facies description. Then we will look for the bioturbation. Okay. Then from this information, we can inherit the environment of deposition as well. Then here we need to write down the formation name. Okay. On the right hand side, we have one software that you can work with this software as well. The name of this software is EasyCore. It provides some of the description similar to this performer. So you can make lithologies, litho logs by using the information from the core. Also, you can upload the log data in order to calibrate your core with the log data. Okay, as I said earlier, that it is necessary to match the depth with gamma ray. Okay, sometimes in a lab they run a gamma ray to just to get the information from this core as well. We can note down each and everything, and we can come up with some depositional model out of this description. So this is the basic step to get the idea about overall to get an idea about overall reservoir characteristics of the core. So core has a prime importance. You just need to get some basic idea that how we can describe cores. I had some of the videos I'll send to you. I have one book that shows how to describe the cores. Obviously, there are some differences as well, because when we will be looking into the carbonates, that is much more difficult than the siliciclastic course description, because the fossils will be our prime investigation in the carbonates, while in siliciclastic, we will be more focused on the grain sizes, sedimentary structures, so that we can inherit the information out of the core. So